Hello everybody and welcome to Handmade Hero, show where we code a complete game live on stream. I don't know that there's anything particularly magical to say before today's episode. We just have to now go through and clean up the lighting code and debug it, which is what I was going to do yesterday, and we actually ended up doing a lot more cleanup than I was originally planning to do, but it was just like getting to the point where the code was just too many things in one place. There was just so much stuff that we had tried and that was still running in line. I was just like, we're going to have to clean this up a little bit. So that's exactly what we did, and you can now kind of see the structure of the code is changing a little bit. And I'm going to go ahead and copy these function signatures out to the outside just so they can be viewed a little bit clearer, so we can see what's happening in terms of the actual sort of flow of using the lighting system. And I think, if I'm not mistaken, we've now got it down to the point where you're excuse me, where you're a lot more explicit about what you're actually going to be doing. And so it's much clearer how the lighting system's actually going. So you can see here the way that we currently have it structured, where you set up the lighting region by telling it what's going on here. You then push the lighting render values on if you're trying to do rendering. You update the lighting. This is after you've already done everything. And then you go to push lighting debug values if you actually want to put like the debug lines on the screen and stuff like that. Now the problem that excuse me, that we have here is just that setup lighting region is something that I'd rather not have to call. My goal would have been to just have one call that's like update lighting. But the problem with that, and the reason that we can't really do that, is because even though the lighting system would work just fine, it's this push lighting render values that's the problem. So the way this works is you can see it sets these light bounds here and does the enable lighting call. Now anyone could do these calls, but so there's not any particular reason that the lighting system has to be involved. But the key thing here is there's this voxel rect, and that voxel rect we only know after we've updated the lighting system. So that's really the reason why we have to have this two-stage process, is because we need to set up these light bounds prior to doing any of the actual pushes that push the entities in the system on, right? So that's the problem we've got. And it's not a problem in the sense of like there's nothing wrong with the code as it is right now, so it's not something we have to fix. But it's just something that would make the code simpler if we could get rid of it, right? If I could somehow make it so that we weren't having to do these two steps, we could just call one step, well, that's just better, right? And so I'd like to figure out some way to do that. And unfortunately, at the moment, I don't really know how I would necessarily do that. So the problem, that I think we're going to have is just like, do I want to try to do anything particularly specific with that? Or do I want to try to leave it as it is and just like live with that aspect of it? And I don't really know which one of those two I want to do. I'm not entirely sure. So we'll take a brief look at it now. Excuse me. And we'll go from there. So when I do set light bounds, what this is actually doing, oops. Got my keyboard is all aligned weird here. There we go. So when I get set light bounds, what you can see is that this is setting this thing called the render setup. And the render setup basically says all the stuff that has to happen for a particular, it basically tells you what has to happen for all of the things that get pushed on after it. So if we set the lighting region and then we go ahead and for each entity we push on, it's sort of underneath that lighting region. It's had that lighting region set. Then it will be lit properly. If we don't do this, then none of those entities know how to look up their lighting in the light voxel. Now, there's other ways we could potentially do this because there's only one light bound in use ever. We don't really compute multiple lighting, and we don't ever expect to do that. So we could do something slightly different, which is to say we could just make the lighting bounds be something global. And if we did that, that would probably solve this problem. And it might be something that we actually do want to do. You know, I'm not sure which way we want to do it, but it's entirely possible that that's like the sensible thing, right? And so if, for example, we take a look, excuse me. If we take a look at Handmade Renderer and Handmade Platform, well, I guess I could just jump right to game render commands. If we take a look at game render commands, what you can see here is, you know, things like the light atlas and the lighting box, like occluders and that stuff, are just out here in the game render commands. We could choose to just put the light voxel in there, right? And if we did that, then you could just set it at the end and you'd be done. The problem with this is it does make the renderer a little less generic, meaning you now couldn't have multiple lighting regions. But it seems to me like that's a pretty okay change. Like, we don't expect to ever have to do that. So it seems like we could just make it so that this is something that gets set once and never changes. So for example, if we took a look at the OpenGL side of things, where this actually happens, it's actually in here. And I don't actually remember what that's called, but I guess I'll just look at the code because I know where the code is. But the voxel dim part of things, right? Then when you look in here at how this actually gets set up, we should be able to see just pretty clearly how that gets dealt with. We would pass the setup to wherever the actual dispatch is. So right here. So what you can see here, you know, ignoring the clipping rect part of this here, what you can see is that when we actually go to use the program, and we're going to go use specifically the zbias program, which is this one, you can see in here that it gets the vox min corner and the inv total dim. It gets those out of the setup. And it could just as easily get those out of something else. There's nothing stopping us from just pulling those out of the game render commands instead. So, you know, I mean, it seems compelling, right? It seems like a good idea. So I may go ahead and try that. What I'm going to do here is I'm going to go over to the game render commands. I'm going to move those over and just see if I like that, right? So let's go to the render setup and let's just pull these two things out. So, you know, rather than having them be part of this particular piece of information for the lighting bounds, instead I'm just going to put them, you know, here in the game render commands. And I mean, I guess one other thing that I'm not sure about is, you know, does this have a problem? Will this cause a problem in terms of like transforms? I don't think so, because we only ever set it once. So we're never updating it based on any other transform information. So I think it's just fine, right? Like the lighting bounds should just be okay. Again, I'm a little nervous about this, but I just don't see any other way to flatten the lighting into just like one straight update call. So if I move this out here, so we have like a lighting voxel min corner and a lighting voxel inverse total dimension, those two parameters that are used now, and you have to get them from the game render commands, I should be able to change the way that this setup stuff works to make that be the case, right? And so now when you call set light bounds, it wouldn't actually push a new setup on to the stack. Instead, what it would do is just set it in the game render commands. And I believe the render group itself, it just has that pointer. I mean, here it is. So I can even leave this call. I think I'm not going to, just because I don't really want it to look like it's working in a push fashion. So I think what I might do is just say, look, you call it to set it on the actual game render commands. So you kind of have to be doing that, right? Right. I'm just not sure. I'm going to leave it this way for now, and then if I don't like it, I'll change it back. So we'll go ahead and get that out of the render group, and then we'll set these two things in there. And then all we have to do is change it so that that information is now coming from the game render commands instead of the setup. So in here, we just need to know what those would be, what those would do. And so we need in here the game render commands to actually be passed. And then in here, we would get those like this. And that's the entirety of the change. So it's a pretty easy thing. Like, there's nothing magical to it, right? And I'm assuming that we just have this on hand because that's the whole thing we're drawing, right? So it's just that. It's already there. It's just something that we weren't using before for that particular pass. So what I might do now is try to flip back to the extent that I can and use the old system real quick. So in here, where we've got the lighting use old KD, I'm going to leave that on. Lighting use for rays, I don't actually know. Are we actually using that? Is that what's actually happening? Yes. So I should be able to still compile this and make this work the old way. And I figured this would be the best way to make sure that this works properly before we go any further, right? Because we're making some changes here, and we have to figure out, like, we have to debug the changes that I've made so far. It looks like compute walk table is still running, which I suppose is fine, although it looks like I've got a bug in it. Let me take a look there. Yeah, so we're not actually updating cost. So we want to do a plus cost here. There we go. Looks like... Oh, that's weird. So, looks like we didn't actually... It looks like we didn't actually if-def that one out either. So, we probably want to if-def this out real quick, because, if we're not using the 4rays version, we don't need this stuff, right? So I'm just going to go ahead and knock that out as well. So this is lighting use 4rays. So if we aren't doing that, then this path is in. There we go. And again, this is just so I can do some debugging with the old version first to make sure I didn't break anything there. And then I can look at the new version separately, right? Okay. Yeah, because you can see there's some busted stuff, right? You know what I'm saying? So we want to go in and fix that first before we go any further. So I just wanted that to make sure that was correct. Also, we're building with OD right now, so we should probably build with O2 for the moment as I'm doing these changes. All right. So what we want to do here is we just need to fix the old lighting and make sure that that's working okay with the new changes that are streamlined, and then try to pull everything out just so it's roughly correct, right? So let's go ahead and go through that process. So now that we don't have to do that set lighting in any particular way, I should be able to now make it so that this is a one-call system, which is what I wanted in the first place. So update lighting can now just be the only call that we actually have. And so up here where we do set up lighting region, I can actually sort of just weld these two together into a single operation, basically. And so when I'm doing that, I just need to make sure that we have sort of all of the information that we might actually need. And you can see here, like, of the stuff that gets passed, basically we just need this additional set of data excuse me, passed to the system. And then we just have sort of one giant monolithic call that updates everything at once. And the reason that I want that is because I would like, ideally, to have one entry point to the lighting system. You call it, it does all of the lighting work, and then it returns to you so that it's very clear the lifetime of everything and what needs to happen. I didn't really like the multi-call nature of it, and I just didn't think that was particularly useful, right? So I think what I want to do here is just say, get rid of that. We're just going to have one update lighting call. The update lighting call is the only thing you actually call. And then there's a push lighting render values call, and you can tell it whether or not you want include debug, right? And maybe, I don't know, maybe we don't even have that. Maybe that particular call actually it's going to do debug or not based on how I've configured it. And the caller doesn't really get a say in that, right? So that's what this would look like. And presumably, if the lighting is not enabled, then we just don't do this. Now, at that point, it also kind of seems like, I don't know what lighting enabled really means at this point. Like, I'm not sure what we're actually trying to say with lighting enabled, because it kind of just seems sort of like an unnecessary flag. Like, if you didn't want lighting, just don't call this at that point, right? So I suspect we probably can just get rid of that. So I think we can remove one of the inputs, right? Because you just wouldn't call it at that point. And that's all there is to it. So I think that's all we really need there. And so we'll just assume that if you're calling that, you want lighting. If you didn't want lighting, you just wouldn't call it. It doesn't really need to do any kind of tracking of that on its own. Now, my understanding on the fundamental unit side of things is I kind of thought that the world knew what the fundamental unit was, but I guess maybe it doesn't, which is a little bit weird, because you would think that the world would have the information about what the fundamental unit was. And so I'm a little weirded out by the fact that it doesn't seem to know the answer to that question, and I would like to know why we didn't do it that way. So I'm just going to quickly take a look at the fundamental unit here, and I'm going to see what's going on. You can see here that in world mode we set the fundamental unit, and then when we create the worlds, we just pass it the chunk dim in meters. I guess the idea is that the world doesn't care what the fundamental unit is, and that's why we don't know, but I don't know. It seems like the kind of thing that the world should probably know eventually. I won't change that now because it's not really the area of the code we're working on. I don't want to make decisions in that part of the code right now. So I guess we'll just like leave it. But you know, you can see why I'm a little bit like, oh, is that really necessary? Okay, so now we have an update lighting call, and the update lighting call should do literally everything. And what I'm going to do is I'm just going to kind of jump back over to the code that's calling that. This stuff obviously doesn't need to be here either. We can kind of pull that part out since it's always actually going to do this. Let's see here. Yeah, all of this stuff can just be left up like so. And then really what we want to do here is just have these calls make a little more sense. So you can see this stuff here now, in theory, shouldn't actually have to occur here. We should be able to go down to just where we actually finish the lighting up, which is here. And in this particular case now, what we should be able to do is replace the debug part with this, and update lighting now will just take additional parameters, but then we won't have to call this set lighting region anymore. So when we call update lighting, we pass the solution, the fundamental unit, which is here, the spec atlas, and the diffuse atlas. It looks like these are in the opposite order here for some reason, which would be very bad. I wonder if that's part of the reason why stuff was looking weird. We have the world needs to get passed, which is this. We have the sim origin P, which is this, and the lighting center, which is this. And then we've got the occluders. I think that's everything. And the compiler will certainly tell us if it's not. All right. So now we just need to make sure that the push lighting render values call, I guess, actually does what we need it to. This is the one thing that it actually needs to do. Enable lighting. What does that do? So render group light bounds. What is the light bounds for? Do we know? I don't know what this is. Root light box. I have no idea what this does. Why do we have this? Does anyone know? Does anyone know what this does? That is literally the only thing it does, is set that value. For no reason. So, I do not know what the point is of that. So, what we really want here is just like lighting enabled, I guess. I think that's what this should have looked like. Yeah. So that's probably all we actually want. And then enable lighting in the world mode stuff just goes up here and where we turn it on. So somewhere up here before we actually do anything, we probably want to turn on the lighting. So like, you know, maybe here. I don't actually know to what extent this stuff wants to be here particularly. Again, this loop probably should get sort of streamlined at some point, but sort of a separate issue. But we would just do an enable lighting here and then probably a disable lighting here, right? So after all this stuff happens, we do false. Now, eventually we should actually use that. We don't even use this right now, but you know, it's kind of a separate issue. I mean, we sort of do, but we don't do the right thing with it, I guess is what I would say. So now we're doing the streamlined version, and now we just have to actually go through and make this not be buggy, right? So also, it's weirdly fast for some reason, and I don't know why. I'm guessing that maybe the bugginess of it made it run much quicker or something. It's like way faster than it was before. So that's a bit weird. But anyway, so this is much better. This is kind of more what I would like. And so I'm going to go ahead and copy these directly in here because these don't need to get pulled out anymore. So I'm going to go ahead and just grab those this way. And now that we have a single way just to call the lighting system and say do the entire update, now I can focus on that side of the code more directly and make sure it works right. So now when we do update lighting, what you can see here is we've got initialization stuff that we want to do, and that stuff can all live in here. We then have sort of like update stuff that involves figuring out how the voxels shift over time, and that's this code here, right? And then we've got sort of our, in fact, this build diffuse light maps now, we actually know where we would cache that. We would cache it right here, right? So that actually gets better too. We then have like the internal lighting core stuff, which runs here, and other stuff where we do the boxes and the occluders and stuff. So I think probably what we would want is to maybe, I think we maybe want to start to streamline this out a little bit too. This is probably not working in the most efficient way possible. So if I take a look at internal lighting core now, I don't know that we actually want this to be separate. This could just be its own thing that happens out of line, kind of. I want to say... I want to say that this can just be welded in now, right? So, what you would do here is you'd just say, well, yeah, I don't know. So the question is, internal lighting core is just something that we may or may not want to update in some way based on how we're doing the external testing. So I may leave that for now, and I think what I'll do is I'll just document this routine as we go through it, and we'll kind of go from there. So what I would say is, this first part here is see if any settings have changed or if we've never been run before, and initialize all our tables. So this is basically, just something that initializes the lookup tables we actually need. And instead of doing these at compile time by making like a meta program that generates them, which we do for the sampling spheres, in most cases we just generate them on the fly. And the reason we do that is because that way we can change these values at runtime if we want to, and it will recompute them. So I think that's fine. And sorry, I'm still feeling pretty sick. It's been like 4 or 5 weeks of being somewhat ill, and I'm not really sure what exactly it is. Anyway, we compute walk table here, and we do, the basic stuff we need for doing our grid march lookups. At the moment, that's not in play. The diffuse light map build we use in all the cases, so that one is the same. But otherwise, I think everything's pretty straightforward. Yeah. I would say that probably build diffuse light maps. I would put it to do on this and say this should probably dynamically allocate the map, just like compute walk table. And so we can fix that one, but at the moment I don't want to touch anything until we return the lighting in the old system to working properly, because I don't actually want to introduce any more possible failure points as we go. So coming through here, you can see us setting up the sampling spheres like so, and setting up the fundamental unit. You know, it occurs to me that I'm not 100% sure if the sampling spheres are still the same. I wonder if there's problems with that, but that's sort of a separate thing we can look at. All of this stuff I think is probably not particularly relevant. Like Voxel dim obviously is computed the same way it used to be. It's just one fundamental unit per side. The spatial cell count here is not used in the old system, so it shouldn't matter. It should only be this atlas grid here that matters. So it's these two values are the only two values that should matter, and we're getting that one right off the spec atlas, so it should be okay. When we come through here, we look up those values and we use them for doing the same computations we were doing before. So here we basically just say, look, where would we actually be in the voxel, you know? How far do we need to move the voxel to account for where we are, is what this is doing. And I assume this should just work fine. I don't actually know why it's doing some of the things it's doing. For example, if we already have the inverse voxel cell dimension, I don't know why we're actually dividing by the voxel cell dim there. It's a little weird, right? Like this is just this, right? So not sure why that was not just using the value it already had, probably because, again, we hadn't really streamlined this code ever, so we didn't actually know that we were being redundant there. But anyway, once we figure out what's going on here, then we update whatever the last origin P was, and we look to see if we need to move the thing. We call the block copy to move the voxels around, which all seems pretty good, right? So that's the initialization. This part of the routine here is update the alignment of the voxels, lighting voxels to the view. And I don't think we changed anything here, though. So I'm not totally sure. I'm not totally sure why we would have been seeing weird flickering artifacts there, because we did have some. I don't. It may not come across very well on the recording. So let me kind of show you what I mean. So when we were running, so you can see that there's two things that are happening. One is that the lighting computation is wrong now, and it used to be correct. And the other one is that as you moved, you see that flash? So it's like the camera is one off there. And so there's a couple of places that could be coming from. It could actually be coming from the world mode. So in the world mode, this camera simulation center, we may need to save that across the boundary. Because this update here will change it. So what we may need to do is say, like, back where we snapped the lighting center, we probably want to fix this. So we probably want to say lighting sim center. And pass that just to fix that error. Oops. Not sure. Yeah, there we go. Okay. So I'm guessing that will fix that problem. Oh, whoops. I don't know what happened there. There we go. And so now I would expect it to be smooth everywhere, and it is. So now we're totally good on that. That's where that bug came from. So now what we need to look at, though, is just like, why is the raycasting and or voxel stuff so strange, right? Like something bizarre is happening there. And there could be any number of reasons for that. And so I think at this point now we want to sort of focus on the other part of the code. But let me just finish doing this. So here's the update alignment code, right? And I don't know why the temp arena thing starts here, probably because that's where that code was. I think I'll just start it here so that anyone can use it anywhere they want to, because it is the temporary arena after all. And then in here where we do the next stuff, let's do update lighting voxels. I guess our update maybe we'll just call it update voxel values. And I could also break this into two stages because one of them is sort of a little bit different here. So we could say update voxel values and record statistics. So up here we're basically saying, like, you know, determine the blend setup. So we're left with something here that then I'd like to take a look at, which is the boxes. Like, I'm not thrilled with how the boxes flow through the system. So now, you know, what I'd like to do is maybe take a little bit of a look at, I mean, I guess, you know, let's not do that yet. Let me actually go debug why we're getting wrong lighting results first. And then I want to come back and take a look at the boxes. Essentially what I want to do here is say, I kind of like this, where's this, to not be stored anymore. So I'd like that to kind of go away. And we can start to move towards that. It'll be real easy to do when we move to the new raycaster. So I might put it off till then, but eventually that should also happen. Anyway. So yeah, so when we do build spatial partition for lighting, I don't think we really messed with that. The split KD stuff we didn't end up wanting to do, and I'm pretty sure we're not going to do it. We can always go back, you know, we've got all the old source code. We can go back and re-put it in if we want to. But I think what I'd rather do here is just say, like, look, let's now just use the two versions, the fastest old version we have and the new one, right? So we'll do if lighting used for arrays, and then we'll do the else clause, and we'll do this build here, right? And we'll just yank split KD entirely. So split KD goes away. It's not actually working anymore. And then we just have to focus on the actual raycaster. I think. I didn't pull anything that we needed there, right? Yeah. Okay. So then we've got kind of multiple paths in here, and what I'll do is I'm just going to kind of remove some of them. Debug-wise, we may still want to do this, especially now when we're trying to do some debugging. So I'm not going to pull that yet. The if lighting use old KD, I'm going to actually let it just run that, and then I'm just going to remove the else clause. So this whole thing is going to go away, like so. I think, what did I do there? How come that didn't, what did I do wrong there? Hold on a second. I don't want to accidentally push. Okay, so it looks like I just wasn't. cutting it quite right. So right there, down to there. And so this is, again, just me like pruning down the code so I can, there was just so many things kind of that we kept putting in for testing, and eventually it gets to the point where it's very hard to work with, right? So we have an if use for arrays, and then here I guess we'd have this still occurs regardless, and then we would drop down to the else case. So I guess this is actually how we would do it, right? Yeah. And so this code has not been changed. It's still updating the spec texels the same way, but I don't know to what extent we may have changed a few things in here while we were doing some of the optimization work. So we may want to verify that any of that is still like working properly. I guess I don't know if we touched anything in there that might cause a problem. But so now we've at least simplified it down. It should look basically the same, and it does. And there's our grid raycast, update voxel. I don't actually know what we're doing with update voxel. Like nothing. So that's just old news as well, because we welded that in, so that shouldn't actually be happening. I like looks fishy. Looks fishy is very good. You gotta understand, sometimes some numbers look fishy, wouldn't you say? I don't know that we really care about that. But you know what I might do? I might stick it in here. Just in case. Just in case. We need to check if something looks fishy. So we've got our voxel irradiance computation, and we did sort of change some of these. Like we did use the get relative p. So we use the voxel utility functions now. Maybe I screwed them up, right? I mean, that's totally on the table, and that would leak into here. Get light leaf for p is like, we're not really going to be doing these anymore. So this can go as well. It's just not a thing. Debug box push we probably want to keep, because we're going to have to debug a bunch of stuff soon, and we would like to fix that. I don't know that getBox is a thing. I guess we're using it just to verify that we don't go out of bounds now, right? So I guess we'll leave it in. And addBox storage we're using as well, I think, right? Yeah, only on the old path though. So we'll leave that stuff for now. Pretty sure the KD stack pack is gone now too, right? So again, not really doing anything right now other than just deleting code so that I can have a little bit more of a focused approach as to what's going on in here. It's just gotten a little bit too crufty to really be able to like suss out what was going on there. And it'll get simplified quite a bit more once we pull out the old caster as well, but I just don't want to do that till I can verify that the new caster is unambiguously better, which we don't know that it is, right? So I just can't make that leap yet. Okay, so same situation here. I don't know that there's lighting points anymore, so I feel like those should be able to be removed. We don't use them. Light node is also not used, I don't think. KD tree node is not used. And I think that is the end of it, right? All right, so this is much more streamlined now, although there still is a ton of stuff in here that doesn't need to be in here once we can actually pick the raycaster we're going to use. So now we just need to address, like, why are we getting this weird light behavior? Like, it's looks kind of like well, I mean, it looks kind of like an issue with the raycaster. I don't know. I think, I mean, I don't really know, but I may have to just kind of re-enable some debug bounds because this kind of algorithm is really hard to debug without looking at what it is, what it actually shows you. So I'll take a quick spin through the raycaster first and see if there's anything obvious that we can just bingo out on and save time. But assuming that, we don't see anything, I think I'm going to have to take a much more methodical approach to it. Okay, so here's the actual light loop. You can see how it works. It's basically just looping through the children of the entry on the box stack. And so the way this works is it just says, look, we're going to start with one box on the stack, and we're going to go ahead and consider that box. And the way we do that is we loop through the leaves that it has, and you can see here it says, like, if we need to actually push something onto the stack, yeah, you can see. So basically, this is the collision detector that says, did we hit this? Essentially, we know for pulling something off. I can see how this works now. I just had to repage it back into my head. We pull something off the stack. If it's on the stack, then we know it's a, interior node. It's not a leaf. It's not an actual, occluder. It's some kind of a spatial partition node. We test it, and we see whether or not it's going to have the correct set of things for us to process it later. So we use should push, which is to say whether or not it was close enough or inside. And we say if we should push and this thing is a leaf container, then we roll over the leaves in a tighter loop, which just streams over them one after the other, and we pull the box out, test against it, preserve the best hits using select, and continue the loop, right? So it's just a little branchless loop that just kind of sits there and runs. It's branchless assuming this is turned into a CMOV, which you hope it would be. But who knows? We did find that MSVC doesn't really turn things into CMOVs unless you're very careful, so it's entirely possible that it actually doesn't. But and then we have another CMOV version down here. This is the thing that does the should push for the box pack, I think it actually turned out to not be faster with a CMOV, though, so we didn't bother. There was something weird about that, right? But anyway, you can see here we just do, look, we update the depth and the box stack if this is something we should have pushed on, right? It seems pretty reasonable. I don't see anything particularly weird going on there. I'm not sure why that would have sort of flamed out the way that we're seeing now. But anyway, we go down here. We finally, when we retire, we know we now have 4 hits. I mean, hopefully, maybe some things didn't hit, but we have 4 ray results. We try to compute what the normals are. That's what this whole thing is. And then we loop over each ray. And in Scalar, we ask it to compute the voxel irradiance. And you can see getting the components out here, and then asking the voxel computation to sample the diffuse atlas and blend it together. So that's, that's all that happens there. Assuming that information is fetched, it then uses the transfer PPS to basically update the spec map in just this little piece of code here, which is pretty trivial, and it hasn't been touched, so I don't suspect there would be much to worry about there. But, I guess you never know. So I think that's basically it. My concern would be that compute voxel irradiance at, let me take a look at get relative p. I'm just not entirely sure. I don't know to what extent that's correct, and I just want to take a look at it. So it's basically saying, look, make the world P be relative. figure out which one it's in, which it does. And then it just produces the UVW. Yeah, it's a pretty straightforward routine. It doesn't seem like it could be wrong. The actual initialization code could, of course, always be wrong, though. So that part's a little bit harder. Let's take a look at that real quick. So you can see here we get the cell count and the cell dim. We produce those, the inverse from those. And we set the cell count. We will set the min corner later by using rect min dim. Working off of the cell count and the cell dim just to produce whatever that offset should actually be. So unless rect min dim was somehow wrong, which doesn't seem plausible at this point because we use it everywhere, but yeah, it doesn't seem like that could be incorrect. So that, I don't know why that would be wrong. I don't know. So again, I'm just struggling to find anything obviously wrong, so I think I may have to just kind of dip down into it and sort of step through carefully to see what's going on. I don't see any obvious explanation for why we would be getting that. I suppose the exterior code, which we did change pretty heavily, could have screwed something up. I mean, in here, if you forgot to set some fundamental value, that would be a pretty obvious way you could have screwed things up because, the code is dependent on all of these values being set because there's just, as with anything, with lighting, there's just so many moving pieces. And so it's pretty easy. You end up with kind of this orgy. If you actually, if you imagine trying to do the lighting as a functional kind of a design where you always pass everything that everyone needs, it just gets really unwieldy very quickly. And that's usually, when you're dealing with a system like that, you also know that there's kind of a lot of cruft in it then, because that just means there's so many moving parts that it is going to be tricky, right? That's just kind of how that goes. So anyway, yeah, so I'm not sure. I would say that I guess I also don't know as far as the lighting spheres are concerned. I don't really remember to what extent we're outputting those values, or I don't know if we even ever verified if we are outputting those values in a sensible way. I assume that they're still correct, but I actually don't know. Like, we generated like a non-interleaved version of this thing or something. And so, I'm just going to go take a quick look at HH sphere just to remember what the last thing we dumped to this file was, because I'm just not sure. So like in here where we do output sphere INL, right? When we did the generate octahedral lighting pattern, I want to say that we preserved it, like, meaning it should be the same thing, like way that it was. So here's the light sampling sphere. And that looks like it's just correctly grouped 4x's, 4y's, 4z's, right? So I don't know. So assuming that this is still, producing reasonable results, I guess, let me just test it, because rather than me inspecting the code, the easiest way is for me to just look at the actual stuff that comes out and see whether or not it's valid, right? So if I go, and I can actually do that in the code as well, when we pull those samples out, I can sort of check to see what their length is, right? So when we are actually doing the raycasting and, we're in the compute light propagation callback here, for example, I should be able to then take a look at the value we're using to do the cast. Well, I guess that's probably down in here, right? And verify that it's actually a, like I should be able to verify that it's actually correct. This looks weird though. So this is odd. In fact, so why does this look like this? Here's sample directions. Okay, so this is wrong. This is totally wrong. Okay, so what it looks like is happening here is that raycast is, we don't have one that's still doing it the way that it used to work, where we would pass 4 ray directions down. I mean, just looking at it, right? Like that would still need to be true. So I think this is garbage now. And you can see that it's not even loading up the sample spheres anymore. So if we do want this to run properly, we need to use both of those things. So we need to do like light sample sphere. And we would need to actually like load that out. So in order to get the sampling sphere, in this case, I think it would be like basically this same thing. It just looks like we were just, while we were doing the other code, we just vaporized the original version here. So this would pull out the sampling sphere in question, and then this would be the thing that would pull out the correct sampling sphere value. So if we just did, you know, array D here where we said sample sphere, I don't remember what that was just called, sample direction. So if we said like, okay, that's the sample direction, in here we'd just say like, oh, okay, like do the ray D that you need to pass, and presumably we can just do 1 and 2 and then update this one as well. Now I have to go verify that that actually works. Is it just that? That's actually what we used to be passing, because I'm not sure. But I feel like that's mostly right. Like that's mostly what we should have been pulling. So let's see. Okay, so it looks like that was probably the only problem. So we just weren't passing the right sampling values. So now if I go ahead and run us in O2 mode, looks reasonable. Like, I'm not sure it's right. Because again, we haven't even really done our lighting quality pass, so we don't really know to what extent the lighting is actually proper, but at least it's not obviously buggy now, right? It's at least more towards the sane side of things. And, you know, looks like more what you would expect. Okay. So what I would like to do here is maybe just because I don't know that I really want to get into the other side of the lighting today yet. Maybe I'll say that for next weekend. What I'd like to do now is just streamline this again a little further. So while I have the lighting in a running form, simplify the code down into maybe 2 discrete branching paths that I can switch between very clearly. The old one and the new one. Just so it's more straightforward for me to be able to like continue to do the debugging properly between the 2 of them. So if I were to try to write it, so you can see that the way the grid raycast here works is, you know, you say, here's the one ray I want, and it returns you the transfer PPS value. And you can see the way the other raycast works is it just does the update sort of at the end, right? And so the problem with doing it this way is, again, just like you kind of have to figure out like what are you actually going to do in terms of the difference in updates. The reason we did it this way here was because this code already happened to be, it was already doing 4 at a time. So when it pulls out of this routine, it's got 4 color values. It made sense to just update those directly into the resulting spectexel buffer. But I'm not sure that that makes a whole lot of sense for the other way the raycast works, because the other raycast routine is set up to just do like one single ray. So you need to do it 4 times in order to be able to pull out this exit criteria, right? Now, maybe that's just better. Maybe we do just want to wrap it in a loop of 4. And so when you call that raycast routine, you'd still do 4 at a time. You just do them serially. And I don't know. I'm going to go ahead and say sure, because again, that allows me to split these two into clean, like completely separated versions. And that to me just seems like way better. So I'm going to call this routine here AABB raycast, and I'm going to call the other one the grid raycast, which it already was. And then I guess I'll just try to wrap the grid raycast routine in this code, right? So in other words, this will actually happen at the top of this code. I don't actually know if casts initiated properly gets updated by 4 in here or not. It does. So this code here will basically, instead of grid raycast actually getting called, it just is the routine now. So it'll loop over the ray index multiple times and produce in here the transfer PPS value. It will not like return it, right? So it's actually gonna just produce it directly. After producing the transfer PPS value, it will do the same writes as this routine does. So, we'll actually streamline it in here. Like so. And then this routine will not have any preprocessor directives in it anymore. It'll just always be what it is. And then we'll just have lighting use grid will be a 0 or a 1. And I'll take a look at the places where lighting use gets used here. And I'll just say, okay, if lighting use grid, then we do it one way. If not, then we do it the other way. And then the raycaster can just be something that gets picked. Yeah. So like in here, we'll just do a $if around these guys. And we'll say lighting use grid, we'll do it one way, and then this will do it the other way, right? So in one case, we update the sample direction. In the other, we update the ray D pull, and that's all we needed to do. So now let's actually call the correct one in these two. So in the AABB case, it's going to look like this. We don't need the final 2 parameters because those were added specifically to support the grid ray tracer, which we know we don't need. And then in this one, the same thing would be true in reverse. Like we probably don't need, oh, well, it already says that. So we know that it's like a different set of parameters, right? So in this case, we know that we would probably pass those 2. So instead of the ray D single, like that stuff, right? We know that these two have to be set to the things we would have passed, right? And so things like the walk table or whatever are not actually going to be, we're not actually going to get those. So diffuse atlas just comes in automatically. Ray origin single is just whatever this ray origin was. So that's getting passed in directly, right? Yeah. So this is just going to get passed in as what we use in the case of this ray origin here. It seems like the spec atlas needs to be in here as well, right? Because if we don't pass the spec atlas, we won't have anywhere to write. So that was an addition that needs to happen. And the same with the spec texel. The sample direction gets passed here in the initial grid index, and that's everything at that point. So then we do our loop, and our loop needs to pull off of the sample direction for the particular ray index we're on to get this ray D, which is what it will do. And that will be called ray D single. And ray origin single is just what we got passed. So that's just here, because it doesn't change. The initial grid index we got passed in. The walk table we pulled out ourselves. And so then I think we're good. Total casts initiated can just be inked by 4 because we know that's what that's actually going to do. And so in order to simplify this, we might just go ahead and say, like, each time through this loop, we initiate 8 raycasts, right? So that doesn't need to be done twice. Okay. So the moon direction, again, we don't really know how this is going to shake out. That's like placeholder code because we just have no idea like what we're expecting to happen there, right? Oops. So we don't really know what's going on there, and we don't really care at the moment. So this is lighting use grid. Grid ABB. Okay. So we should be able to now swap between these two lighting versions. Pretty straightforward, right? And now we have completely separated calls for each one, so they're, you know, completely unrelated and don't like overlap each other at all in theory. We do have 2 separate calls here, so we have a build spatial partition for lighting for AABs and a build spatial partition lighting for grids. And what I might want to do is actually just split those 2 out as well. So again, we have just one like point where we call them and see if we can make that work correctly. Yeah. So I'm going to try that. I'm going to say like build spatial partition. And I'm going to have like AABB and grid. And I'm just going to try splitting this routine into 2 halves to see if I can make that work or not. So if I grab the part of this routine that does the AAB build, it looks like this. And then if I take a look at the part that builds the grid routine. Looks like this. And it seems like there's probably like very, very little overlap here. You know, just looking at it. So I think that should be pretty straightforward. And now I can just do here, if lighting use grid, we call the grid one, otherwise we call the other one. And now we've kind of like pulled this code apart to the point where we don't, like we could even make this be like hot swappable, right? Now we just have effectively a switch we turn, and we run completely separate code paths for each case, and they're really not at all. So we could run them together, right? We could run them at the same time without the pound if, right? By just using an actual if in the code. And that seems good, just as something we can use going forwards. So let's go ahead and run the old AAB one. And so the other thing I would like to do here is maybe clean up the way the box storage stuff works in this particular case. That's another thing I would like to do. But let's just see. So when we do the grid lighting, there was like a ton of bugs in this. That's supposed to be grid raycast. And so we could also maybe try to look for some of the bugs. Like we've got asserts and stuff. We had accidentally disabled asserts by accident. So we've got bugs in here. That's an assert. I should probably go to debug mode. So yeah, if I run in debug mode, I should hit asserts on things not being in bounds. You can see here, like we've got an index, and the index is apparently garbage. So if I take a look at the cell count, you can see that it's fetching it's like 1 ahead of X where it should be. So basically, like this particular piece of code here, somehow this clipping to the spatial grid bound like wasn't sufficient to prevent the index from being out of bounds, which is a little bit weird. It's a little bit hard to see here. 29.4. What's the actual total bounds? Interesting. I would like to see this. So this one is right on the edge. So I guess the problem that we would have there is that on the absolute edge of the box. So since we don't want to step over the edge of the box, we would want to bring the actual like total bounds that we're clipping. We'd want to bring them in by 0.5, since it wouldn't change the results, but it would make sure we never step out of bounds. So what we probably actually want to do is we want to use like our region clipping, you know, or a clipping region, something like that. And what we would want to do is say, you know, take this thing, and so when we produce the box bounds in both cases, what we want to do is, once we do that clipping, we would want to do a Minkowski sum on that. I do have that, don't I? Yeah. Do we not have it? I guess we just called it add radius to. Yeah. So what we'd want to do here is we'd want to just do an add radius to, otherwise known as Minkowski sum. But in this case, it's just a radius, so you can't add two shapes, I guess. Whatever, doesn't matter. Point being, I want to add to the clipping region effectively like a negative shrink of half the cell dim. So whatever the cell dimension is, I'm shrinking it in by half so that I clip everything just to the to that region. I think that would work. The only thing I don't like about that is maybe we don't quite want to do it all the way into there, because the downside of doing that is just that, well, this has an apron anyway. So actually, technically, we want to shrink it by one whole unit, don't we? I mean, really? Because we're not supposed to be putting things in the apron anyway. So actually, that's probably fine. Because we don't really care if things are in the apron. We're not gonna look at them either way. So that way we won't have anything that goes outside the region due to the rounding, right? So let's take a look at if there's any other ones here. So that looks like it's still overlapping on Y there, right? Why is that? Pun intended. Show me. Okay, there we go. Because the clipping region should now be shrunk. Such that you shouldn't ever be able to step outside like that. Although, I'd have to go actually verify that that's really true. But so it does still look like it's for some reason in Y anyway, thinking that it can continue to do that. But I'm not sure why. Oh, wow. We're not even using it. Check that out. So this actually needs to be box bounds, right? So that's pretty obvious there. So that was just a case of like, because the routine had been written prior to the clipping, it was actually using the direct box bounds there, which is not at all what we actually wanted. So, oops, that's a comma. All right, so now we fixed two potential bugs in that sorting routine. Let's see where else we get assertions here in the grid lighting. Okay, so you can see that basically, like, if you call the grid lighting routine, you end up with basically just straight moonlight in a weird way, right? So every direction hits nothing, right? You see what I'm saying? So basically, like, you run it, every direction returns moonlight, and it immediately goes to like fully saturated moonlight, and there's literally no direction that doesn't produce moonlight, apparently, right? Let me pull out to a further out. You can see the lighting bands there. So that's good. I mean, we're at a reasonable point now. I don't know how much time I got left. We have like a half an hour. So I think that we will want to maybe push a little further down into there today. What should I do? What should I do with my half hour? So I'm not 100% sure what I should do with my half hour. Trying to figure out whether I should try to get this working or whether I should go to the... let's finish the cleanup, and then we'll start next weekend on that part. All right, so let me switch back to the grid version here. I mean, the non-grid version, rather. And what I wanted to do here was I'd like to start to remove some of the stuff that's getting stored in the lighting structure that really probably should not be in the lighting structure. So if we take a look at the way getBox is working, I think that's the primary thing that I don't really like. So if you look at where add back storage is actually being called, you can kind of see what's going on here. Like basically everywhere that we're doing our splits, like we add these boxes in, right? And these boxes are now, we generate boxes for every particular case, meaning we never actually use the original boxes that were passed to us. And so what I'd like to do is I'd like to just stop storing that array. And so what I'd like to do is basically take a look at this and say, okay, like this is going to be some other thing, right? And we will still use it for our own internal storage. So that can continue happening. Oops. But everywhere else that we use it, actually, why isn't this calling getBox? I have no idea. Oh, wait, but that shouldn't be calling getBox, should it? Because these are source boxes. So that should actually be looking in the actual box array. Yeah. So actually what we want to do here is we want this to be complete. Yeah, okay. So what I'm trying to say here is I want this to pull these source boxes here out of like some kind of source box thing, right? Like in here we would say lighting box, you know, input boxes or something like this. So then like when you pull something out of the source here, you're pulling it out of like input boxes like that. And everybody else is using the getBox part of things, right? Which we could probably remove at this point. So this code would look more like that. And then when we call the split box thing, we would pass in the original boxes. So in here where we do AABB build spatial partition, we would just pass like actual box count and or like input box count and input boxes. And in that way, we wouldn't really need actual box count either. You know, this would just be input box count. And I don't think we want the root lighting nonsense either. Like, we're not using that anymore. So let's just get rid of that. So basically what I'm saying here is we pass in the input boxes and we wouldn't store them anymore, and then this AAB boxes thing would be something we would actually allocate. So much like this routine here allocates using a push array call, the spatial grid node set, we would do the same thing here. So we'd just say like, yeah, whatever, man. The temp arena now gets a lighting like solution AABB boxes equals push array, you know, max light box count, who cares? Lighting box. Right? So we just put that on the temp arena and we don't really care, like it doesn't matter, and it's not an issue. We then go through and, you know, we use input boxes everywhere for when we're actually reading out of the input stream. And I think that's really it. I mean, that's... So that's all I really wanted to do there, was get rid of that kind of weirdness where it's getting stored, like the input boxes are getting stored and we put them onto the same array for some reason like that. I just was like, nah. So anyway, if we do it that way, then both of these routines can get past the input box like set, which to me feels a lot more sane. So then instead of actual box count, it's just input box count and input boxes. Yeah. Okay. And in this case, for the child box stuff, this is actually going to pull out of the AABB boxes. The split box calls are just going to take the input boxes exactly as they were before. So nothing particularly special happening there. And same thing with this. I guess in this case, this is a 16-bit value. Yeah. So I think that's fine. And so now we kind of need to fix the debug dump data stuff, but which is totally fine. And I guess I'll just nerf that for now, and then, because I'm going to have to decide what I actually want, where I actually want that to be, and I'm not 100% sure. Result lightboxes is kind of irrelevant at this point, so that's probably just not going to happen anyway. But, you know, we'll see when we actually get there. So now we can just pass, all right, when we get in here to the internal lighting core, the internal lighting core would take the input box count and the input boxes as actual parameters, which is a lot better because that way, you know, you kind of know what you're actually dealing with here. So it would be input box count, lighting box, input boxes, like so. And I don't know, like we may just want to like say that that has to be a 16-bit value because we don't use more than that. I don't know whether we want to do that or not. It's hard to say. So when we actually call internal lighting core now, we would pass the occluder count and the occluders like that, and this would go away. And I guess I didn't remember what that actually takes. Yeah, what's the complaint? Temp arena came first, that's why. So it's temp arena and then those two. There we go. All right. So at that point, yeah, I don't know. This is all the hprof stuff. which I don't really care about very much in here. So I'm going to go ahead and nerf that real quick. There we go. And now I guess I'm going to just verify that this stuff all runs properly. And we can move on. All right. So in here, wait, are we in debug mode? No. All right, so one problem we're going to have here is that when we have to initialize these somewhere now. So like, I guess when I do AABB build spatial partition, I will also need to kind of like set this value up. So AABB box count has to be 0 when we start there. I suppose it actually technically has to be 1 because I think we leave a slot. Like 0 is not an actual valid lighting box. So that's kind of a separate issue, but. So that seems fine. And so now I think we're getting a little closer to what we actually need here. So then if we actually take a look at handmade lighting, so we could now also ensure that people don't fuss with these if they're not using the correctly corresponding version of the two. So like, you know, if you go to the central switch now, we could move the central switch up to the top of the H file, and then we could use that to determine which set of spatial partitions you actually had. So we would compile out the ones that you don't have, if that makes sense. Which might also just make sure things are a little bit better in terms of like consistency. So now we should be okay. The only thing here is that the like split box stuff, like all of that, and calc ref c, yeah, like that stuff should also be in that if, because these things should not happen either. If you're not compiling that in. So if you're using lighting use grid, then great. And if you're using the other one, then you also get these other routines, if that makes sense. Where was the end of that function? Right there. So now I think we're compiling all of the code one way or the other as well. And again, there's no reason for that. I could just remove those, but I just wanted to verify that nobody was using like both, like that everything was clean. One, you know, if you do it one way or do it the other way, nobody's like looking at somebody else's data structure there, so that I know that they're completely isolated. So I think now we have a clean switch between the two of those systems. And, you know, whichever one you choose is the one you get. And they build their own intermediate data structures, and they never share, right, either. So I think that's good. So we're getting closer. So now that that's done, I'm just trying to think if there's anything else that I want fixed up. And then, like I said, next weekend can just be just for debugging the grid walk code. And that should be it for that. So that all looks fine. I think like the debug line stuff should probably be in the temporary arena now. So like these don't need to stick around. So I think, you know, if we take a look at where that's being used, and we just go debug lines, right? Let's just see everyone who's using it. I mean, that's pretty straightforward. So I think we should just be able to do this. And then we can allocate the amount of debug lines that we actually want. So maybe at the top of things we do that. So there is an interesting thing we could do there, which is to say, like, we could do that just only if we don't have any of them. So, like, we could do something where we said, like, when we do push lighting render values, we push all the line segments out here, and then we say, like, debug line count equals 0. And after we've done that, we know sort of the temporary memory would get freed. So in a sense, we probably have to, if we were going to do that. Yeah, so I guess the reason not to do that is just that we don't actually have the ability to persist those across. You know, it's like ambiguous how long they should last at that point. We could just put them in the table memory, and maybe we'll do that. So maybe what I'll do is I'll say, all right, solution debug lines equals push array debug line. And I don't know how it knows what the max debug line count is. It was array count here, which is not what I want. So I probably want max debug lines, right? And it would do that. I think that's probably fine. So we just say max debug line count equals however many we want the maximum to be. And then we just need that value to exist. I think that should do it. Oops, I forgot to tell you that it's solution table memory. All right. So I think now we're pretty good. That feels nice. And it just feels a lot more manageable now because we've got those pretty buttoned up. Nothing really squirrely happening now. Everything's pretty, pretty easy to take a look at now. So I guess the only other thing I would say is internal lighting core is now sort of a little bit on the table. So I would be interested to know whether I still want that to be its own function or whether update lighting should just have the whole thing in it. And mostly what that's about is just determining whether or not I think it would be easier to have it be callable from the external code. And I really am not sure. Yeah, I'm not sure. I don't know about that. That's a tough one. And I guess I would say I'm not sure. Yeah, I'm not sure what we want to do there. I can roll that in, but at the same time, like, I'm not sure how we would necessarily compute the stats. We could use the debug macros to do that if we wanted to. But like if we take a look at HHLightProf here, and in terms of how we do our pound defines, I'm just not sure. You know, we turn off Handmade internal and Handmade slow there, right? And that's to get rid of those pound defines. And we could just pound define them back in and use the debug data itself in that case, the debug output itself. And maybe that's the best option. I'm really not sure. If we don't, we're going to have to call this function, right, with the data that we get here. That's not so tough, though. If you look at what's in there, really you just have the sim origin P, the origin P, the input boxes, and the atlases, and we could just dump those. I don't actually know what the heck it needs world for. It's probably just for alignment. Yes, you can see here, like, it needs, like, the operations on the world struct. And that's kind of a little unfortunate, because it would be nice if we didn't depend on the world struct. And you can see that the subtract call actually, let's take the non-stub on this one. Yeah. So if you look at like the subtract call, like the only reason these things need the world is because of the chunk dimension in meters. And I'm assuming like R in the same chunk is the same thing too. Actually, you don't even, it's literally just for an assertion in that one, right? So I kind of feel like we probably just want versions of these that don't need that, and then instead of passing the world in, we would just pass the chunk dimension in meters. At that point, it becomes possible to create a flat struct, and you can call the whole thing exactly as is on in and out. That seems way better. So like, I think the other thing that I would then want to do is the following. I would want to make a struct here that's like lighting update params or something. You know what I mean? And this would take the chunk dim in meters. It would take these two saucy gentlemen here. And I guess that fundamental unit. And that way you would say, like, here's the parameters and then here's the pointers. And when you want to snap a debug output version, right, you just use the parameters. Now, I think that means I also probably want to go ahead and pull the random series, I'm guessing, as well. So, like, I guess I don't know, but I'd like to take a look at how the entropy flows through it. And it would be nice if you basically said here, like, look, the random series comes in here as well, so that that's also, like, repeatable to the extent that you want it to be. So if you pass the same parameters, you get the same result, and there isn't, like, a stored state. So, look, if you look at the lighting solution, and you look at what's in here, you know, at this point, I guess what we could do is just say, maybe this is what that is. So Yeah, like I wonder if maybe the best thing to do here would be to say, look, all of this stuff is regenerated. The random series isn't, so it probably should come out and be in a separate thing. The same with this stuff too, right? Like I feel like we could make one more transformation to this code. And I guess I don't want to do it in 5 minutes, but like I feel like we could make one more transformation to this code where basically like at least from this point, from the update lighting call, it's functional to the outside. Like, so you pass in all the state and it does the work and updates the things without having any stored state that you didn't give it then, right? So in other words, the lighting solution thing would kind of disappear and there would just be two things. What is the stored state you want it to operate on and what is the new state you're passing in? And those two things are both like savable. So this, and the only reason I'm saying this is so that we can go to a nicely repeatable test setup, which we know we need. So I might go to Q&A now and just put a to-do in here that says like, you know, split the lighting state into pieces so we can have a more functional-esque way of calling it where the two halves specify the persistent and new state so we can save them both easily if we want. And basically what I mean by that is like right now this lighting solution structure is doing double duty. It is both the thing that we use to avoid having to pass 8,000 things to everybody in the actual lighting code, because that gets extremely slow. You want to be able to just pass one pointer and know you can access all the stuff for efficiency, not to mention typing. But it's also the thing that carries the persistent storage. So like this diffuse weight map and the sampling spheres and all this crap, that's in there too. It would be nice to split those things out so it was clear, like, here's the stuff that's like cached and stored over time. Here's the stuff that's like regenerated automatically, and it's really just for efficiency. So like, you know, just to be specific, it looks like this. So you can see, right, you can see there's 4 separate types of information that are in here, right? And each one of those types has a different behavior. And so what I'm saying is, look, we should probably, figure out the most effective way to split those into pieces so that it's clear what each one does and they're not all mixed together, right? Because I don't think they need to be for any particular reason, and it would just be easier to work with, easier to understand, and easier to save the state if we had those clear pieces, right? So now that we're starting to get a very clear picture of how this whole thing works, we can start to make those changes accurately. All right. Is max node index supposed to be inbounds or one past the bound? It's supposed to be inbounds. I'm not sure I know exactly what you're talking about, but I'm assuming you mean inside the grid build space partition routine. So I'm assuming you mean this. It's supposed to be inbounds. Does the lighting solution support direct lighting like the sun and moon? So at the moment, there is a moonlight, and it's just assumed to kind of be, it's more like a skylight. So it's just generally a dome where it's brighter if you are aligned with the direction that the moon is in and dimmer as you get further out. I don't know that that's going to stay in there that way. We may change that. We probably will. So, you know, that was kind of just the thing that was in there temporarily. So that'll probably get modified a little bit. But obviously we do have, we do want moonlight in the game. So there will be some way that moonlight applies. I just don't know exactly how we'll end up wanting that to be encoded, because things that are underground shouldn't have moonlight applied. So doing it the way we're doing it now is probably not how I would do it. Are we doing this on the CPU purely for educational reasons, or is there something else? I guess the reason is because, at least at the moment, we really don't want to require really high-end graphics cards. So, you know, a Core i7 from a few years ago and a graphics card from a few years ago will run the game just fine. If we try to do like an RTX version, like that really limits the number of platforms you can actually run this thing on, right? So ray tracing on the graphics card is not super fantastic. If you are also requiring the graphics card to do all this other stuff, which we do, right? Like we actually used depth peeling to make nice compositing, and we use MSAA to have kind of nice smooth edges and stuff. So, you know, we were using the graphics card to do stuff. And we can't just pile things on the graphics card forever. So doing it on the CPU seems like a good thing because it's nice to have that option. And then eventually, if we want to move that to a GPU computation, well, we would want it to be on the CPU anyway, because you really don't want to debug your lighting code on the GPU. Like, oh my God, right? So I guess what I would say is that's, you know, I think no matter what you plan on in shipping, you should probably have it working on the CPU side first, because it's the only way you're going to probably debug it very well. Because GPUs just are very hard to debug. They don't even really let you step through code most of the time. Certain cards did, and then now they don't. I don't know. It's pretty weird, but... Can I comment the UE5 demo? I already did. We can put mirrors in every level like Labyrinth. Mirrors wouldn't work particularly well in this system because we don't have any way to render mirrors. We can bounce the light off of them, but the actual renderer that renders like sprites and stuff wouldn't actually work, right? Like we don't have, the renderer doesn't try to do that at all. So we would need something in the actual, we would need to put like a ray tracer in the actual pixel shader to do like the rendering of the mirrors, as opposed to just allowing the mirrors to bounce light around for the lighting solution, which that would be trivial. It would just be that you wouldn't, you would add spikes to the spec maps for those things because they would bounce directly rather than diffusing, right? Can you go over the AVX scatter gather intrinsics? I've never used them. The last time I saw the AVX scatter gather intrinsics, they were still Larrabee intrinsics, or I should say actual code, like actual ASM. So I don't actually know what they put in there. Presumably they look similar, but I have no idea. I actually didn't, if you'd asked me, but like I said, I haven't looked. If you'd asked me, I didn't actually know that AVX itself had scatter gather, as opposed to AVX 512. But maybe it does. No, so I'm right about that. So there really isn't an AVX scatter gather, I don't think, unless I'm missing it. It's only in the AVX 512. Like, it's the Larrabee instructions that have the scatter gather. But, you know, I'm guessing that, you know, if you just read the thing, it should be pretty clear, like, what it does, right? I would imagine. Yeah, I mean, they're just, so these, I don't know if you remember, but, like, I've lamented many times that, like, the SSE and AVX instruction sets, not AVX 512, but the first two instruction sets, they didn't have a way to do memory fetching 4 wide, 8 wide, 16 wide. You couldn't do that, right? So what you typically end up with is you'll do something like you'll do a computation and you'll say, where do I need to fetch my texels from or whatever? And you're doing this for 8 at a time. And all of a sudden you have to downshift into scalar. Like, you've seen this literally in the lighting code just now in compute Voxel or radiance at. So this function is almost always in a situation with the, when we were trying to do the AAB raycaster. So in the AABB raycaster, what you see is like it comes down here and it has to downshift to scalar to do the voxel irradiance computations, right? And this is just a huge pain in the butt because what you'd rather do is just keep it 4 wide and do them 4 wide. Now in the grid ray tracer, we don't care. We can choose to bundle up to 4, but we can keep it scalar. It's one of the nice things about it for SSEs. It just kind of works if you do the grid raycast way, but separate issue. So anyway, inside the compute voxel radiance call, we would like to be using the get tile clamped thing wide, but we can't because you can only access memory off of general purpose registers. So what the scatter gather intrinsics do finally is they just let you say, look, give me an address, but then you can pass me a vector register, right, that will actually have in it the indexes that I should then go fetch for each individual lane, right? And so scatter and gather are just ways of writing or reading to different memory locations using indexes per lane rather than having to downshift to scalar. But that's it. Like, that's all they do. Now, they're awesome in that you really want instructions that do this. So when I say that's it, I don't mean like it's unimportant. I just mean it's very simple. But it's really, really great because once you have these, if they are actually implemented fast in the chip, which at the moment I don't actually know if they are, but like when they get them high performance eventually, hopefully, maybe, right? And maybe they already are. Like I said, I've not tried them because I don't even have a chip that can do this, I don't think. Maybe I do. I don't know if I have a Core i9 that may have scatter gather. It may not. I don't know. It has AVX 512F, I think, but probably not any of the other AVX 512 things. It doesn't matter. The point is, if they get this working well, it's great because now you can keep everything wide. So you don't have to worry anymore about the problems that you have when you've done all your computations in nice scalar form, and nice lane form, and having to downshift auto scalar. Does that make sense? But there's really not much more to it than that. It's just that's all it is. Do you have any idea how the gameplay will look like, or will you wait to finish the engine before getting to it? Yeah, so the gameplay stuff is really not my thing. So I would say that like we just do engine programming here. Like gameplay stuff is not really going to be interesting. So, I mean, when we get to gameplay, that means we're basically done. And that's really, like I said, it's really just not my thing. I'm not a game designer. On the RSI front, I would say two things. One, try to optimize your editing configuration to not use modifier keys at all. So get rid of Control, get rid of Alt as much as you can. And start doing a variable, like a diverse hand exercise sport. So rock climbing was hugely helpful to me. The only other thing I would say is don't use gamepads. Gamepads also seem to be bad on your hands in terms of cramping and tendonitis and stuff. So maybe just like stop playing console games. Those are the only three things that I know. I suspect it's different for everyone's anatomy. So those are things that have been helpful to me. If your anatomy is similar to mine, they'll probably help you. If it's very different, probably won't, right? Probably covered in some other day, but what's the best update rate to choose for a game? John says it's good to have it high so it looks good in high update screens, but 120 FPS isn't a multiple of 144 FPS, so what do you recommend? So that's a good question. So I guess what I would say is like, for my purposes, most stuff I want to make is usually like more of a 24 frames a second kind of thing. Like I care more about cinematic stuff than I care about action-y stuff most of the time. Handmade Hero is kind of a different sort of game than I would normally make. So to my mind, I'd be like, oh, 24 frames a second sounds good, and we'd just do 120 or 144 based on that. But I guess I'm not sure what you would do if you want 120 frames a second and 144 frames a second and you want to have a fixed frame rate. I would say maybe what I would do... So I would say 144 frames a second sounds like it kind of sucks. I would maybe tell people who make 144 hertz monitors to stop because that sucks. It doesn't even evenly divide a sample rate. So like, this is good. This is very good. You see what I'm saying? So like 24, 50, 60, 120, 30, right? Like 4,800 samples per second is like perfect for all monitors except for 144. So I would basically say like, set your sample rate to 240 as your core sample rate and tell people with 144 hertz monitors to stop. 144 was a bad effing idea, is what I would say. As far as game design stuff is concerned, it's not really like whether I want to do it or not. It's more just like I'm not going to teach game design. Like this stream is supposed to be like me explaining what's going on, but that's just like not like I don't have anything to explain about game design because I'm not a game designer. You know? It's like I'm not going to like teach a subject that I myself don't do. I would just be making stuff up. All right. Let me make sure this is in a reasonable state. Yes, good. All right. Thank you, everybody, for joining me for the Sarasota Handmade Hero. It felt good to clean up the lighting code today. It was kind of bugging me a little bit, so I'm glad that's been taken care of. I will be back here next weekend to start to look at debugging the grid ray tracer, and then we can take some good performance samples and see where we're at in terms of throughput, and we can maybe make some educated guesses about that, looking at the VTune profiles and so on. That's it for today. If you want to follow along the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code, so you can follow along with it. And if you want to, you can try debugging the grid ray tracer this week. You could certainly beat me to it. I don't think there's a whole lot of bugs in there, probably. It's probably just a case of stepping through it carefully and fixing all of the little issues that come up. So I'd highly recommend giving that a shot. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.